Alright guys, happy snow day. This is a lesson that we're actually going to do tomorrow. I'm flip-flopping those 2 days, so we're going to still do our in-class assignment when I see you guys next on Tuesday. This is an introduction to the inverse trigonometric functions. I'm also going to have you guys do a short Desmos activity just to see the graphs of the other functions because it'll help you to understand this lesson a little bit better. So the first question is, can sine have an inverse? So if we look at this and we go back to what we learned, I think in chapter 1, if we look at the graph of sine looks like this. In order to have an inverse function, we need to make sure that it passes the horizontal line test. So if we look at that, it does not pass the horizontal line test. So sine cannot have an inverse because it doesn't pass the horizontal line test. So then we get into the talk of inverses with sine. We're going to talk about cosine and tangent as well. And we can have an inverse for them. We can assign them an inverse if we restrict the domain. So that's the part that's going to be really important today, is that we're going to have restrictions on the domain. The restrictions on the domain for sine are that we can have an answer out of it that goes between negative pi over 2 and pi over 2. So if we were looking at that graph I drew up here, we looked at this graph I drew up here, we're looking at answers here, answers here, and answers here. Those are the answers we're looking for. So there's 2 ways that we denote inverse sine, either arc sine, which might be one you haven't seen before, or sine -1. Those both mean the same thing. The arc sine is kind of a little bit more fancier way of saying it. So we can have an inverse for sine if the x values, the input values for x, are between -1 and 1, and then our answers that we are going to get out are between negative pi over 2 and pi over 2. If you notice, this is going to be switched of the domain and range of regular sine, the x and the y switch, because we're talking about inverses. So x can only be from -1 to 1. That's what we're allowed to plug into it. And then the answer we're going to get out is going to be an angle. That's really what we're searching for. Our angle has to be between negative pi over 2 and pi over 2. So let's look at a couple of example problems. Alright, so here's some example problems. We're going to be actually just thinking in reverse. They're giving you the answer. You're searching for the angle. So in order to do this, the first thing I want to look at, let me draw it over here off to the side, is we're really looking at either the hand trick or you're going to make the chart, but however you memorize this before, you need to really know what the answers are at each of these points. So this is over 1 up 0. This is over radical 3 over 2 up 1/2. This is over radical 2 over 2, comma, radical 2 over 2. This is over 1/2 up radical 3 over 2, and this is over 0 up 1. So we're thinking about those special points that are on our unit circle, and we have to report an answer that is either, if it's positive, it's going to be in that quadrant. If it's negative, like this first example, we're actually going to have to think of the values that would be down here. This is what you're thinking of. And the negative angles that would go with that. Okay? So actually it might be helpful to write in, this is 0. We're going to answer in radians. This is pi over 6. This is pi over 4. This is pi over 3. And this is pi over 2. And again, that the range for sine, the inverse of sine, goes from negative pi over 2 to pi over 2. So now we're thinking about negative angles down here if it's a negative answer. If it's a negative value that we're searching for. So with that being said, let's look at the first example. We want to find arc sine of -1/2. So I would look at the positive 1/2 value. So sine, remember, is the second value. So it's 1/2 at pi over 6, which means it's negative 1/2 at negative pi over 6. That would be this value right here. Now we want sine -1, inverse sine of radical 3 over 2. So again, we're looking at those outside values and finding the answer where it's radical 3 over 2, and that's pi over 3. And that's just your answer. You're just searching for the angle where that happens. Now if you look at number 3, we're trying to find the inverse sine of 2. If we look at those outside values, we don't get 2. And if you remember, when we graph sine goes intercept, max, intercept, min, intercept. It only is going to go up to 1 and then go down to -1. So this value here, the x value, has to be between -1 and 1, and this is not. So this is, there's no answer here. This is not in the domain. Alright, number 4, actually if you want to pause it for a second and think about these next 6 answers, this is what I was going to have you do in class. So if you pause it, maybe jot these down real quick, make sure you understand what's going on. I'm not going to go over the answers. So arc sine of 1, I'm looking for where that's +1. So +1 is going to be at pi over 2. Arc sine of -3, this is going to fall into the same case as 3, as sine can only have an input value of 1 to -1. So that's the only thing we can input for a inverse sine function. So this is not in the domain as well, so you can't get an answer here. And then arc sine of pi, or radical 2 over 2, radical 2 over 2 happens at pi over 4. So this is pi over 4. And we're now going to apply this all to the other trig functions, and this will be a little bit easier to understand if you've looked at the Desmos graph stuff that I'm leaving for you to do as well. So we already did arc sine. We're looking at arc cosine and arc tangent. So the graphs are below just to give you a feel for really what we're looking at here. This is the only part of the graph for sine that we could look at and have the domain be something where there actually is an inverse. If it went any farther, then we wouldn't have an inverse. The cosine one is the one that's going to be different. The cosine one, the range is different for us to look at. We're going to look at the range from 0 to pi. So our answers are going to be, instead of, this one's technically the first and fourth quadrant for sine. For cosine, we have to look at the first and second quadrant, because cosine is actually negative in the second quadrant, versus sine not being negative there. And then tangent is going to behave the same way as sine, as we're going to look at the first and fourth quadrant. We're looking for the range to be between -pi and pi. So those range values are important, because that tells you how you can report your answer. Your answer has to be between the values they're asking for here. So let's look at the next page to look at a couple more examples. So again, we're looking at the unit circle. So I'm going to draw that out just again over here off to the side. Oops. So we have it. This time we have tangent in the mix too, so we have to think about what those tangent values are. I honestly will be using my hand trick here. That's what I would be doing. But you could also write this out each time if this is really helpful to you. Or you could write out your chart if you have that memorized. You put the chart down and then you're just using the chart in reverse. They're giving you the answer. You're trying to find what angle that happens at. Zero, pi over 6, pi over 4, pi over 3, pi over 2. Alright, so we want arc cosine of positive radical 2 over 2. So I know cosine is that inside one. So arc cosine is going to be looking for the angle in radians. Pi over 4 is where we get an answer of radical 2 over 2. Arc tangent of 0. So that's when we divide sine and cosine. So this might be helpful to write out the arc tangent values here. So 0 divided by 1 is 0. This is going to be radical 3 over 3, this is 1, this is radical 3, and this is undefined. And so we know that it has a value of 0 at 0, so our answer is just 0. Another arctangent 1, arctangent of negative 1, so we can look at our graph and we know it's positive 1 at pi over 4. Arctangent, we're looking at either the first quadrant or the negative angles that would happen if we went the opposite way. So we would be looking in this direction for arctangent. So we're looking at what this value would be. That's the one that would match. And that's going to be negative pi over 4. So that's the answers you have to give me. If it's negative, have to be in the negative quadrant. Alright, number 4 is cosine of negative 3 pi over 2. So the cosine one's the one that's going to be weird, is we actually aren't looking in the fourth quadrant, because the fourth quadrant cosine would be positive in, as we need to think of a space where it's negative, so we're actually over here in the second quadrant, because cosine would be negative there, and we have to find where it would be negative pi radical 3 over 2. So that is here at, at pi over 6, but we need to figure out that value that it would be in the second quadrant. So that's really going to be, if we gave a reference angle of pi over 6, it's really going to be pi minus pi over 6 to figure out what that value is. So that's going to be 5 pi over 6. So you need to make sure for cosine inverse that you're giving me an answer that's in the second quadrant if it's a negative value. The sine and the cosine, we're going to the fourth quadrant, the negative angles that would occur in the fourth quadrant, but you have to give me a second quadrant answer for cosine, because that's where cosine would be negative. Cosine's never negative in the fourth quadrant. I hope I'm making sense here. Alright, this is the point where if you wanted to try these next two, just to see if you've got a handle on it, give it a try, and then you'll be doing a little bit more practice in the homework. So if you pause, I'm going to go over the answers now. So now we want arctan of negative radical 3. So I know we have radical 3 up here at pi over 3. Now, since it's negative, we're going to have to think of where that happens in the second quadrant. It would just happen here in that mirrored spot, which would be negative pi over 3. And then arc cosine of positive 1. So I'm looking again, that's the first value. So here's positive 1 for cosine. That's going to happen at 0. So the gist with these is they're giving you the answer, you're going backwards, you're trying to find the angle that happens at. What you have to be careful with is how you report that answer, especially when it's negative. If it's positive, it's going to be a first quadrant answer. But if it's negative I'll write this down, for negative angles, for sine and tangent, you're looking at quadrant 4 and giving the negative answer that would have the negative angle that would be in quadrant 4. For cosine, you need to look at quadrant 2 and you have to be giving me an answer that would occur in quadrant 2. Okay? So try the ones on the homework. It's a pretty short assignment. And then you should also be doing the Decimos activity that I'm leaving for you to do as well. And we'll be checking all of this on Wednesday, as tomorrow we're going to be doing the in-class assignment. Alright, hope you enjoy your snow day, and I will see you guys soon.